Hello, this is for assignment 31. It's assigned on April 9th. So it's the one on today for Tuesday. And I'm going to go through the problems or at least give hints. Number 1, we have a circumscribed polygon around a circle. And the definition of a circumscribed polygon is that each side is tangent to the circle. So these are tangents. And one of the ways we can find missing sides is to remember that 8 plus x, opposite sides, added together are equal to the other pair of opposite sides added together. So 8 plus x equals 10 plus 12. And then you solve for x. That's number 1. Number 2. This is an inscribed quadrilateral. It's inscribed, so every vertex is on the circle. And when you have an inscribed quadrilateral, opposite angles are supplementary. So it's quick to find y here, because 100 plus y equals 180, and you can solve for y. The same is true for x. X plus 70 equals 180, so you can solve for x. When we look at the arc here, arc Z, it is the arc on this inscribed angle. This inscribed angle right here, highlight it. This angle here is inscribed on this arc. Inscribed angles are half the measure of their arc. So if this is 100, then Z is 200. Number 3. Angles that are formed on the interior by these two chords are equal to 1/2 the sum of their intercepted arcs. So this angle 50 is equal to 1/2 the sum of 60 plus x. Multiply both sides by 2 gives 100 equals 60 plus x. And you can solve for x. That was number 3. Number 4. Now we have chords that intersect inside the circle. So the segments have a special relationship. 3 times x is equal to 5 times 6. And I'll let you solve that for x. Number 5. Angles that are formed outside of a circle, in this case by two secants, are equal to 1/2 the difference of the two intercepted arcs. In order to find A, however, we can use the idea that the measure of the arcs add up to the entire circle of 360 degrees. So A equals 360 minus whatever 90 plus 100 plus 100 is. So that's 360 minus 290. So it looks like A is equal to 70. So if A is equal to 70, these all should add up to 360, and they do. And in order to find angle B, which is on the exterior, is equal to 1/2 the intercepted arcs subtracted from each other. Well, the smaller one subtracted from the larger. So this angle is equal to 1/2 the difference of these two arcs. Multiply both sides by, no, I don't have to do that. I can just combine this to be 30 and 1/2 of 30 equals 15. So B equals 15. Number 6. Now we have segments that are created by two secant lines here. And when we want to look at the relationship here, we'll need to look at the external segment, the external secant segment, and the entire secant segment. And this is an external secant segment, and this is the entire secant segment. So the relationship for number 6 would be 6, the external secant segment, times the entire secant segment is going to be equal to the external secant segment here times the entire secant segment, which is 12. 5 plus 7. 6 times 6 plus x equals 5 times 5 plus x. Distributing gives 36 plus 6x equals 60. And I'll let you go ahead and solve that for x. Number 7. Number 7, we need to find x and y. I can immediately find x when I see that this is an inscribed angle. Inscribed angles are half their intercepted arcs. So if 35 is half of x, if 35 is equal to half of x, then x is equal to 70. Just multiply both sides by 2. This is 70 because this inscribed angle is half of it. If x is equal to 70, then you can find y by adding up these two arcs and subtracting them from 360. 70 plus 120 subtracted from 360, and you will find y. Number 8. Number 8 uses some information about tangents. This exterior point here, it's outside the circle, but some tangent segments have been drawn from that point to the circle. Remember, lines that appear tangent are tangent in our homework. So this is a tangent segment and this is a tangent segment, and because they're both tangent from the same exterior point, they're congruent. So 2x minus y is equal to 10. 2x minus 6 is equal to 10. And you can solve for x. And now to solve for y, if you can remember the shortcut, angles that are created outside of the circle that are tangent, created from tangent lines, are supplementary to the minor arc. So y is equal to 180 minus 110. Or you could say x plus 110 is equal to 180. These two angles are supplementary. You could do it the long way, but okay, so now you can solve for x right there. X equals, or y equals 70. If you did it the long way and you couldn't remember that relationship, although we did prove it, I proved it in class, let's look at the long way. This arc right here is 110, so the rest of the arc, because these are tangent points, these are points of tangency, the rest of this arc is 360 minus 110, so that's 250. Exterior angles are equal to 1/2 the difference of the two intercepted arcs. So y is equal to 1/2 the difference of 250 minus 110. That's 1/2 times 140, and so that's 70. Either way, it's good practice. Number 9. Number 9 is an inscribed angle on a semicircle. It's half of its intercepted arc, which is 180 degrees. This is a right angle. So y equals 90 degrees. And now we have a right triangle. But I don't think we'll even need to use that information. to find x, we can see that this is an inscribed angle on this arc. This inscribed angle on this arc is equal to 35. It's half of its intercepted arc. Okay. Number 10. The arcs that are congruent have congruent chords. Arcs that are congruent have congruent chords. So 2x minus 6 is equal to x plus 10, and you can solve that for x. 2x minus 6 is equal to x plus 10. Number 11. We're told that this chord is equal to 6. And here is a perpendicular segment from the center of the circle to the chord. Perpendiculars to the chord will be bisectors of the chord. So because this segment here, if we were to extend it to make it a radius, the theorem says that radii that are perpendicular to chords meet them at a right angle. So this is 90 degrees, and it bisects this segment. So this is equal to this, or congruent. Which means that AD is 3 and DB is 3. CD is also 3. We're told that this segment here is 3. Find the radius. Well, the trick here is to draw a radius from the center of the circle to the end of the chord. So now I have a radius drawn here, and to find the length of that radius, I can use the Pythagorean theorem. Here's a leg and here's a leg. So you can use the Pythagorean theorem to find the length of CB, and I'll leave that to you. Number 12. The radius of a circle is 5/2. Find the circumference and the diameter. Okay, so the radius is equal to 5/2. The diameter is going to be twice that. So 5/2 times 2 is equal to 5. So the diameter is 5. To use this to find the circumference, we can use the formula C equals 2 times pi times r. If the radius is 5/2, or we could use, by the way, C equals pi times d, which is a little faster. I'll do it the longer way. C equals 2 times pi, and the radius is 5/2. Extend that line. Cancel the 2's. C equals 5 times pi. When not asked, go ahead and give the exact answer. Number 13. A circle has circumference 2 pi squared. So the circle has circumference 2 pi squared. Find the radius and the diameter. Now here are the formulas. So I'm going to use this formula. I'm going to rewrite this very carefully here. C equals 2 pi times r. My circumference has been given to be 2 pi squared. So that's equal to 2 pi times r. And I'm asked to find r. To find r, I'll divide both sides by 2 pi. So r equals the 2's cancel, and I have 1 pi here and pi times pi here. So that's the same thing as pi times pi. So I can cancel one of the pi's, and so r equals pi. The diameter is twice that, so the diameter equals 2 times pi. Now, just because I like to double check that I've done my simplifying correctly, here's my radius. My radius is equal to pi. I'm going to put it into my formula. C equals 2 times pi. And I get C equals 2 pi squared. That is what the original statement was for the circumference of the value, so I did it correctly. Number 14. Find the length of a 72-degree arc in a circle with radius 10. L equals, the length of an arc equals the angle over 360, the central angle or the measure of the arc, either one, times 2 pi times the radius. It's a 72-degree arc, and 2 times pi times 10, and then you can simplify here. Well, I could cross off the 2, that makes it 180. I cross off the 10, this is 1 and this is 18. And now I need to simplify 72 pi over 18. I believe that can be simplified with, let's try 2 first. 36 over 9 pi looks like 4 pi. And that is the length of that arc. Number 15. Find the degree measure of an arc with length 10 in a circle whose radius is 20, exact and with 2 decimal places. Okay. So when I'm looking for a measurement other than the length, I don't like to use L equals x over 360 times 2 pi r. I like to use the proportion. So L over 2 times pi times r equals x over 360. So I am told that L is 10 and that the radius is 20. And I'm trying to find x over 360, or sometimes it's referred to as d for degrees maybe. Okay, so I could simplify a little bit first before I cross multiply. That's how we solve proportions. So this could be down to 1 and 2. I get 1 over 4 equals x over 360. Cross multiplying gives the result of 4x equal to 360. X then equals 90 degrees. So for 15, I get x equals 90 degrees. Oh, I made a mistake somewhere. I lost my pi. There's a pi right there. So that is x times, I forgot my pi. 4x times pi equals 360. So x equals 90 over pi. So that's the exact answer. I'm going to redo that just to show you. Since I don't know how to edit yet, I'm going to redo. So I have 10 over 2 pi times 20 equals x over 360. And so when I simplified, that became 1, that became 2, and I have 1 over 4 pi equals x over 360. So I apologize for that. Now I cross multiply, and I get 4 pi times x equals 360, and then x is equal to, dividing both sides by 4 pi, 360 divided by 4 pi, and that can be simplified to 90 over pi. And I'll leave you to put that into your calculator to find the approximate answer. 90 divided by pi and the approximate answer. Number 16. It doesn't say here, but what I would like to have is the ratios. So for 16, the sine of A is opposite over hypotenuse. We have to find the hypotenuse, however. So we can use the Pythagorean theorem to find the hypotenuse. The hypotenuse is 6 squared plus 8 squared, square rooted, and it's 10. This is the Pythagorean triple. It's a multiple of the 3, 4, 5 Pythagorean triple. So the sine of A is equal to opposite over hypotenuse, that's 6 over 10, and you can simplify that to 3 over 5. cosine of B. Here's B. Cosine of B is equal to adjacent over hypotenuse, so that's 1/2. And tangent of C is equal to opposite over adjacent, so that's 10 over 10, so that's equal to 1. And then in 17, we're asked to find the actual degree measures. You can use the sine inverse of 3/5, and that will give you the angle A. And you can use the cosine inverse of 1/2, and that will give you angle B. And you can use the tan inverse of 1, and that will give you angle C. Okay. Good luck and happy studying.